A comprehensive backup policy in Azure is vital for ensuring business continuity and safeguarding critical data. By defining rules related to frequency, retention, and workloads, a well-designed backup policy helps mitigate the risk of data loss caused by hardware failure, cyber attacks, or accidental deletions. In this unit, the focus is on how to create and configure these policies, building on previous lessons that introduced Azure Monitor's capabilities and the importance of tracking infrastructure performance and events. Backup policies typically revolve around establishing a schedule, daily, weekly, or monthly, while determining retention periods based on compliance needs or business requirements. The Azure Backup Service uses Recovery Services vaults or backup vaults to store restore points and maintain versions across various resource types, such as Azure VMs, file shares, and on-premises workloads through integration with Microsoft Azure Backup Server. Understanding these foundational elements is critical for reliably protecting data in dynamic cloud environments. The Recovery Services Vault acts as the core component for managing backup policies and recovery points in Azure. By centralizing data replicas in a secure vault, administrators gain a singular control plane for all backups, whether they originate from Azure VMs, Azure storage accounts, or hybrid environments. Through a unified interface, it is possible to configure backup schedules, enable encryption, and execute restore operations for diverse workloads. This mechanism not only simplifies operational tasks, but also ensures compliance with corporate data retention standards. Additionally, the Vault can leverage advanced replication protocols across different Azure regions, facilitating geo-redundancy when required. This approach enhances both high availability and disaster recovery objectives, while seamlessly integrating with Azure Monitor to provide alerts and insights on backup job success rates, performance, and potential issues. By understanding how the Recovery Services Vault functions within Azure's broader ecosystem, administrators can effectively manage backup life cycles and ensure data resilience. Before establishing an Azure backup policy, carefully assess the prerequisites to ensure a successful implementation. Begin by reviewing capacity planning for your Recovery Services Vault, ensuring it is properly sized for the anticipated data. Confirm whether default limits in your Azure subscription, such as storage or region availability, require adjustment or expansion for your scenario. Evaluate your security needs by deciding on encryption models, including the use of customer-managed keys if required by regulatory compliance. Additionally, consider necessary role-based access control permissions, RBAC, to restrict or delegate policy creation and backup operation tasks. Verify that the workloads, virtual machines, databases, or file shares align with Azure Backup supported infrastructure. Validate networking configurations, particularly for hybrid scenarios where on-premises environments will be included. By investing time in prerequisites, you eliminate potential roadblocks and ensure that your backup strategy seamlessly integrates with Azure's robust ecosystem, minimizing disruptions to critical operations. When creating a backup policy, it is essential to define foundational components: scheduling, retention, and workload targeting. Scheduling determines when backups are triggered, often aligned with low usage periods to reduce performance overhead. Commonly, organizations leverage daily or weekly schedules, though critical systems may necessitate higher frequency. Retention, meanwhile, dictates how long backup data is stored before expiration. This can involve short-term retention for rapid rollback and long-term retention for meeting regulatory requirements. By aligning retention objectives with compliance mandates, organizations avoid unnecessary cost overruns while protecting essential records. Workload targeting ensures the policy covers all intended resources, including specific VM disks or entire storage accounts. This granularity enables a refined approach. Only needed volumes or datasets are captured. Clear definitions for scheduling, retention, and target selection make policies robust while reducing operational complexity. Different workloads within an environment may also require separate backup policies for maximum flexibility. One of the most critical aspects of a backup policy is the frequency at which backups occur. Administrators must evaluate the recovery point objective, RPO, requirements that align with business needs. For instance, financial databases with real-time transactions could mandate more frequent snapshots than dev/test systems. Azure Backup supports varying schedules, allowing daily or weekly backups, and in certain scenarios, even multiple backups per day. To optimize resource usage and network bandwidth, scheduling can be timed during off-peak periods. It is vital to plan the backup frequency in harmony with data change rates and the potential impact on performance. Further, administrators should incorporate alignment with other automated tasks, such as system maintenance or patching, to avoid contention for system resources. By carefully balancing system load, cost, and data recovery objectives, organizations can design backup schedules that provide optimal resilience and minimal disruption to ongoing operations. Retention policies determine how long each backup snapshot is kept. These can be tailored to meet diverse regulatory requirements or internal policies. Common patterns include short-term retention for daily or weekly backups, medium-term retention for monthly points, and long-term retention for quarterly or yearly archiving. The table below illustrates a sample breakdown of retention intervals. Retention interval typical use case. Daily/weekly recent versions, monthly critical trend analysis, yearly compliance requirements. By combining these intervals, organizations achieve a layered approach that ensures both immediate restore capability and historical data retention for audits. Careful planning helps strike an optimal balance between compliance demands and cost, since extended retention usually entails higher storage consumption. Adapting retention to each workload's life cycle further ensures logical data governance without compromising on essential recovery points. A backup policy should clearly delineate which workloads or resources are included. Azure supports backing up entire virtual machines, specific databases, file systems, or even specialized workloads like SAP HANA. Defining the scope ensures that critical systems receive the necessary coverage without incurring extra costs on non-essential data. It also clarifies whether to include system state data or only application files. Some environments require granular control over specific VM disks or folder paths to optimize storage utilization. Configuring backup scopes in Azure Backup typically involves selecting the resource type and specifying associated settings within the policy framework. For hybrid setups, the Azure Backup Agent or Microsoft Azure Backup Server, MABS, extends coverage to on-premises servers, capturing physical assets or hypervisor-based virtual machines. By methodically identifying which assets are crucial and aligning them with targeted backup scopes, administrators can ensure robust protection while maintaining efficient resource usage. Automation is key to managing and scaling backup policies across multiple workloads. Azure offers PowerShell and Azure CLI modules for scripting policy creation and updates. With these tools, administrators can streamline tasks, such as assigning a new VM to a policy or modifying retention rules across numerous resources at once. Below is a simplified PowerShell snippet that outlines how to create a backup policy. PowerShell hashtag example snippet $vault equals get AZ Recovery Services Vault. Name my recovery vault. $policy equals AZ Recovery Services Backup Protection Policy. Vault ID $vault.id. Name my backup policy. Workload type Azure VM. Set AZ Recovery Services Backup Protection Policy. Policy $policy. Retention policy $retention settings. By integrating such scripts into pipelines, organizations benefit from consistency, reduce human error, and maintain visibility over policy changes. Whether using PowerShell or Azure CLI, automation best practices elevate agility in backup administration, particularly in large-scale environments. Once a backup policy is established, monitoring its effectiveness becomes essential. Azure Monitor provides key metrics such as backup job status, data transfer rates, and storage consumption, enabling administrators to detect issues promptly. By creating custom alerts, administrators can be notified if nightly backups exceed a predefined window or if a particular VM fails to back up. Additionally, Integrated dashboards deliver centralized visibility by correlating backup health with other Azure service metrics, such as CPU usage and network throughput, which altogether present a comprehensive operational picture. Leveraging Azure Monitor Insights helps identify patterns or recurring failures, informing potential modifications to account for resource constraints or concurrency conflicts. Proactive monitoring ensures that any deviations from expected performance or scheduled operations are promptly addressed, thus maintaining alignment with service-level agreements. Continual visibility into backup processes also supports capacity management by revealing trends in storage usage and the need for policy adjustments. Implementing Azure backup policies warrants thoughtful cost management. Although pay-as-you-go models provide flexibility, large-scale backups can accumulate substantial fees if not properly optimized. One tactic is to carefully set retention intervals based on regulatory obligations and actual business needs. Retaining unnecessary backups for extended periods leads to inflated storage costs. Another strategy involves periodically analyzing usage patterns to identify overprotected resources. Azure Backup's tiered storage system, locally redundant storage, LRS, versus redundant storage, GRS, offers additional cost control levers. Administrators can select less redundant tiers if compliance and risk analyses confirm that such configurations suffice. Additionally, automated usage reports can be exported to Azure Cost Management for deeper analysis. Fine-tuning backup policies with data lifecycle considerations ensures financial efficiency without compromising data availability. This balanced approach allows organizations to leverage Azure's robust backup features while maintaining predictable cloud expenditures and adhering to anticipated budgets. Regular testing of backup policies is invaluable for guaranteeing the reliability of restoration procedures. Through test restores, administrators verify that the specified schedules, retention periods, and point-in-time recovery settings function correctly. This process often involves provisioning a staging environment where recovered data can be compared against original files or databases to validate completeness and integrity. Conducting test recoveries at various intervals, daily, monthly, or after policy changes, helps pinpoint potential configuration errors, such as missing resources or insufficient retention. Additionally, it is advisable to document acceptable restore duration and ensure the backup methodology aligns with the recovery time objective, RTO. In regulated industries, evidence of tested recoveries might be required for audits. Continuous validation provides meaningful insight into the effectiveness of the policy, enabling adjustments to schedule frequency, retention length, or encryption settings. Routine testing stands as a fundamental measure to ensure that backups remain consistent, accessible, and aligned with evolving business continuity needs. Troubleshooting backup issues in Azure often involves reviewing diagnostic logs and telemetry data. Azure Backup and Azure Monitor generate logs for each backup operation, detailing timestamps, storage usage, status codes, and error messages. Administrators can enable diagnostic logging within the Recovery Services Vault settings or use Azure Monitor to gather relevant operational data across multiple services. Log queries in Azure Monitor enable filtering for failed jobs, cross-referencing error messages, or isolating abnormal behavior during scheduled backup windows. By correlating these logs with metrics, such as CPU and network usage, administrators can identify root causes, including bandwidth constraints or misconfigured credentials. These data-driven insights also facilitate proactive measures, like adjusting backup windows or modifying policy parameters. In environments with strict compliance mandates, advanced logging options allow deeper analysis of encryption events or changes in data classification. Moreover, exporting logs to external systems provides flexible archival, further supporting comprehensive root cause analysis and streamlining operations. After implementing backup policies, continuous refinement ensures alignment with changing workloads, budgetary constraints, and compliance updates. As organizations introduce new applications or retire old systems, backup requirements might shift accordingly, necessitating policy adjustments. Periodic reviews assess whether current schedules still meet business needs, or whether certain data has grown in criticality and warrants additional backup frequency. Automated resource discovery features in Azure may help identify recently added resources lacking coverage. Administrators should also monitor available new features in the Azure Backup Service, as Microsoft frequently introduces enhancements or expanded workload support. Modifying retention schedules or migrating selected backups to vaults with more suitable storage redundancy are common adaptations. Ultimately, ongoing policy refinements maintain efficiency and reliability, ensuring that data protection strategies remain aligned with an evolving technology landscape. By regularly evaluating usage patterns, costs, and operational requirements, organizations can effectively sustain a robust, secure backup environment over the long term.